Okay, yesterday we have seen the start at the block 2, second block, that we have seen homogeneous equations. Homogeneous differential equation, on that we have seen the problems. Okay, 13 members are there. So homogeneous equations means we have to see on the left hand side and right hand side, both the degrees should be equal, that is power should be equal. So when you divide that, you will get the power as, that is lambda value as 0. Then it is called as a homogeneous differential equation. For the will substitute y equals to v of x. If you differentiate that one, dy by dx equals to y plus x into dv by dx. Okay, so that is the procedure of the non-homogeneous. So you have the chance of getting for non-homogeneous or homogeneous, both the questions for the 10 marks questions. Okay. Now if we go to the non-homogeneous equations, so those will be in the form of non-homogeneous. Okay. So those will be in the form of ax plus by plus c. So it is equal to, or else we can write small this one. That side is big one. A into x plus by plus c is equal to dy by dx. D is equal to capital AX plus capital by plus c. Okay. So like this, the questions will, if you write this one, this will be the form of dy by dx is equal to ax plus by plus c divided by ax plus by plus c. So if any given question is in this form, then we can see that it is a non-homogeneous differential equations. So those equations, you have to convert them into homogeneous equations. Okay. So when you convert them into homogeneous equations, the procedure will be the same one. Okay. So for this, to convert non-homogeneous to homogeneous, we will put, that is small x equals to capital X plus h and small y equals to capital Y plus k. And we need to find the h and k values. And if you substitute in this equation, then it will be converted into homogeneous equation. Okay. So we'll see one example here. So that is x plus y minus 1 into dy is equals to x plus y plus 1 into dx. Okay. So if you write this one in this form, dy by dx equals to dy by dx is equals to, this is the side, x plus y plus 1 by x plus y minus 1. Okay. So if you see this one, here 1 is there, here 1 is there, but here the term we are having, it is not having any degree. And here also power 1 is there, power 1 is there, here it is not having any degree. So all the terms should have the same degree. So such type of problems, it is called as a non-homogeneous differential equation. And in this also, two different type of non-homogeneous equations will be there. So that is one, case one will be, that is A1 into B2 minus A2 into B1. If it is not equals to 0, so here we have capital A1, capital ABs, instead of that, even you can take it as A1, B1, and that is C1. Okay. So like this also, A1x plus B1 y plus C1 by A2x plus B2y plus C2. Okay. So like this you can take, or like this. So when you take here the values, if that value is not equals to 0, here in the given question, if you see, this is A1, so dy by dx, this is A1, B1, and this is the C1. This is A2, B2, C2. If you substitute here, A1 into B2, so 1 into 1 minus, and here we have A2 and B1. That is 1 minus 1 is equals to 0. We are not getting it as not equals to 0. Okay. So if you get the problem, it is not equals to 0, then we have to substitute this one. This is x equals to capital X plus H, y equals to y plus k. Okay. So, but here for this problem, you are getting it is equals to 0. This is 1, this is 1, this is 1, this is 1. So 1 minus 1 is 0. So such type of problems, you have to see that in the given question, any term you can take it as a common. So in the numerator, x plus y is there. In the denominator is also x plus y is there. So you can assume that as any t or z or any variable. Okay. So when you assume it as any other variable, you have to convert this into that variable. Okay. Such type of one, this is the one method, and this one is the another method for the non-homogeneous equations. Only like these problems are very rare. Only 2 or 3 problems are there. But comparing of this one, the problems will be more. MEQ questions and whatever the example problems are there, there will be the not equals to 0 only. Okay. So here you can substitute here x plus y equals to substitute x plus y equals to z. Okay. Now you differentiate this one. When you differentiate this one, what you get? X differentiation is 1. 1 plus y. When you do another variable other than x, you have to write the differentiation. So y differentiation is dy by dx equals to z differentiation is dz by dx. Okay. So we need here dy by dx that you have to convert into z variable. So from here you take dy by dx is equals to dz by dx minus 1. Okay. So this you can take it as equation 1 and this is 2 equation. Now substitute this 2 in 1. So substitute 2 in 1. So when you substitute here, dy by dx value is dz by dx minus 1 equals to x plus y. What we have taken it as z. So it is z plus 1 by z minus 1. Okay. Now whole whatever the equation is there, that is converted into z variable. Here z is the independent variable. Okay. X is the dependent variable. So here y you will have normally we are converted it into z. In homogeneous, how you will do? You will convert it into v, no? Here also same like that only z. So 2 types of non-homogeneous problems will be there. One is condition if it is not equals to 0, you have to put this one. If it is equals to 0, like this, some terms you will have the common, then you have to do the simplification of that one by taking any another variable. Okay, remember that one. Now dz by dx is equals to dz by dx is equals to z plus 1 by z minus 1 minus 1. Sorry, plus 1 minus 1. If it will go that side, it will become plus 1. So now we do the simplification. It is z plus 1. If you do the cross multiplication, plus z minus 1 by z minus 1. So 1 will get cancelled. It is equals to 2z by z minus 1. Okay. Z by z minus 1. Now we have to apply the variable separable method. So on variable separable method, so here it is dz by dx. Okay. So if you cross multiply this one, what we will get? Z minus 1 by 2z into dz is equals to dx. Okay. Or else z minus 1, you can take this to that side. Here nothing is there, no further x variable is not there. So you can take it as a constant. So if 2 into dx, z, why? Because dz should be in the numerator. So when you cross multiply this one, z minus 1 into dz, by here z is there. This 2 you are taking with the dx. Now on integrating, okay. So on integrating, what will get? Integration of this z minus 1. So you can divide it, no, z by z means 1 minus 1 by z into dz is equals to 2 you take outside into dx plus c. So on integrating, what you will get? This one integration is whatever the variable it is there, that is z, and 1 by z means direct I am doing the integration. If you want, you can separate this one, that is integration of 1 into dz minus integration of 1 by z into dz. Okay, so 1 by z means it is log z, it is equals to 2 into this dx is x plus c. Okay, so it is z minus log z equals to 2x plus c. So what is z starting we have taken? It is x plus y. So here it is implies x plus y minus log of x plus y minus 2x equals to c also is the right. Since x plus y equals to z. Okay. And here one more conversion is there. What is that? Here 2x is there, here x is there. This you can write it as minus x, no? So y minus x minus log of x plus y equals to c is the solution. Okay. Here whatever the homogeneous equation is there, non-homogeneous equation, if that a1 b2 minus a2 b1 value, if it is equals to 0, this is the procedure. If it is not equals to 0, then you have to follow the second one. Okay. So those problems will be very lengthy one. So we can see the problem means actually it will be 2 pages. We will try one problem. Almost 2 papers we will get that one. So this is the procedure if it is equals to 0. So if the value is not equals to 0, what is the method? So one more example is, that is dy by dx. Already it is in the form of dy by dx equals to 2x plus y plus 6 by y minus x minus 3. Okay. Now you see this is a1, b1, c1, a2, b2, c2. a1 into b2. a1 into b2 means 2 into minus 1. Minus a2 into b1. So 1 into 1. So 1. So how much you will get? This is minus 2. Minus 1 means minus 3, which is not equal to 0. So now you can apply here. So take it as equation 1. In the solution, you will only write this as equation 1. Now substitute small x equals to capital X plus h, small y equals to capital Y plus k in 1. And even small dy by dx is equals to capital dy by dx. So now it will be converted into dy by dx x plus h, that is 2 into capital X plus h plus y plus k plus 6 by that is y plus k minus x plus h minus 3. It is if you multiply this 2x plus 2h plus y plus k plus 6 by y plus k minus 6 minus h minus 3. Now this is 2x plus y, you write the variables 2x plus y plus 2h plus k plus 6 divided by, first you write here, okay, by minus x is there, no, if you want you can write this here, minus x plus y minus h plus k minus 3. Okay, so from this we have to find here by this here 2x plus y and minus x plus y are the x variables. Whatever the terms are there for h, k and the constant term, these two we have to take them as a equations and we have to find h and k values. Okay. So here you can take it as a equation 2. So where h and k are chosen to satisfy, that is the take the equations 2h plus a plus 6 equals to 0. This has 2, no? So 3. Next minus h plus k minus 3 equals to 0. This has a 4. Okay. So here if you do the subtraction of this one, you will get from the equations on solving 3 and 4. Okay, directly I am doing here. So this is minus will become plus, this is minus, this is plus. So k will get cancelled. This is 3h. And here you will get it as plus 9 equals to 0 implies h is equals to minus 9 by 3 means you will get minus 3. So h value is minus 3 here. Substitute this 3 value in fourth or third equation anywhere. Okay. Substitute h in 4 you will take. Okay. So it will be minus of minus means plus 3. 3 plus k minus 3. So minus 3 plus 3 both will get cancelled. So what will get k value? K value is equals to 0. So we got k value as 0 and h value as minus 3. So now substitute h comma k into the second equation. Okay. So you will get it as capital dy by dx is equals to 2x plus y plus h value is minus 3. So minus 6. K is 0 now. So if you take out that one, it is plus 6 by minus x plus y minus of minus, it will be plus 3 and it is minus 3. Okay. So just once we have not seen whether it is a homogeneous or not, it's same. If you see the question, the degree of x is 1, y is 1, but we have the constant term is there. And in the denominator also same like the term. So you should have all the variables and they should have the same degree. Okay. So that's why if it is in this form, you can see it easily identify that it is a non-homogeneous differential equation. Now if you see here, minus x and plus 6 will get cancelled. This 3 and this 3 will get cancelled. So constant terms are gone. Now what are they? 2x plus y by minus x plus y. So this you have 1, this has you have 1, here also 1, here also 1. Then you will get lambda to the power of 0. So this is now homogeneous differential equation. Okay. So if you take this as fifth equation, therefore phi is homogeneous equation. Homogeneous differential equation. So now when it is a homogeneous differential equation, what is the procedure? We have to substitute y is equals to, so put y is equals to ux implies dy by, here you take it as capital, okay? You have capital no, so capital Y equals to u into capital X. So dy by dx is equals to x value is 1, so u plus x into du by dx. Okay. This is UV rule. So x differentiation is 1 into u plus x is constant here and du differentiation is du by capital dx. Okay. So don't forget that one. Now substitute in the y. Okay. So dy by dx, what it will become? U plus x into du by dx is equals to 2 into x plus y is u into x by minus x plus y is u into x. So if you take x common in the numerator and denominator, x into 2 plus u by here minus so we can take here x common, you write the u here. So u minus 1. Okay. So u minus 1, this x you cancel it. So 2 plus u by 2 minus, that is u minus 1. Okay. Now same procedure, you take this u to that side. x into du by dx is equals to, because you know now one, so 2 plus u by u minus 1 minus 2. If you simplify this, that is do the cross multiplication. So you will get it as 2 plus u minus u into u is u square. Minus into minus is plus u by u minus 1. Okay. Now it is enough. When you take out this as minus u square plus 2u plus 2 divided by u minus 1. So dx into du by dx is equals to minus u square plus 2u plus 2 by u minus 1. Now the variable separable method. So by variable separable method, if you do the cross multiplication, du should come the numerator. So by minus u square plus 2u plus 2 into du is equals to dx. Cross multiply, that is you will get dx by x. Okay, there in the numerator x is there, that will come as a denominator x. So now on integrating, you take this in the new, you can take it as minus common here. So u minus 1 by, if you take out minus common, it is u square minus 2u minus 2 into du equals to dx by x. Okay. After this step you write. So minus, you take it as a numerator, so it will be minus of minus 1 by u square minus 2u minus 2 du is equals to dx by x. Now on integrating, on both sides. Integrating on both sides, minus you take outside, it is u minus 1 by u square minus 2u minus 2 into du is equal to integration of 1 by x into dx plus c. Okay. Now we can convert this into, we have seen starting one formula now, that is f dash of integration of f dash of x by f of x is equals to, that is log f of x plus c. So here you can convert this one. Why? Because you can't do direct integration this one. So you have to convert it into any other method. So here u square means differentiation is 2u and minus 2u. If you do the differentiation, you will get here 2. Why? Because u differentiation is 1, it has a coefficient 2. And here minus 2 is the 2. If you do the differentiation constant term, it is 0. So in the numerator, if you multiply with 2, then it will be converted into integration of f dash of x by f of x. Okay. So for that, you multiply and divide with 1 by 2. Okay. So minus 1 by 2 into integration of 2 into, direct I am writing one more step, it will come. So 2u minus 2 by u square minus 2u minus 2 into du is equals to integration of 1 by x into dx plus c. Okay. So now it is in the form of u square differentiation is 2u minus 2u differentiation is 2. This is constant term, so 0. So now we can write it as 1 minus 1 by 2 log of u square minus 2u minus 2 is equals to log x. Okay. Log x here, whenever in the integration, this is actually constant of integration. You know already from the definition of the indefinite integration. So here when you get on the right hand side and left hand side, if you get the log terms all, then you can write for log c, that is constant C, we can write it as log C. So log A plus log B means it will be log Cx. And here you are able to see now. So this is log u square minus 2u minus 2 this whatever minus 2 numerator or denominator anything, this minus 2 you can take that set. Okay, right hand side. So it will be minus 2 log of Cx. Okay, now this log and this log both will get cancelled. So what is remaining? So this log of u square minus 2u minus 2 is equals to, you can write it as log Cx to the power of minus 2. Okay. So now this log and log both will get cancelled. It is u square minus 2u minus 2 is equals to Cx. Capital X to the capital X to the power of minus 2. Okay. Constant term will not have, so only for x to the power you write it as C x to the power of minus 2. Now x to the power of minus 2 means this you can write it as C by x square. No? The denominator if you take. So C by x square. So now substitute this whatever the capital X is there and you have to eliminate y also. So for that you substitute what we have taken capital Y. That is capital Y is equals to ux. Now what will be u value? U is equals to y by x. Okay. Now you convert into this one. So what is u value? Y by capital X whole square minus 2 into y by x minus 2 is equals to C by x square. So if you do the square of this one, it is y square by x square minus y by x minus 2 is equals to C by x square. If you take the LCM here as x square, you will get it as y square minus 2xy minus 2x square equals to C by x square. So x square gets cancelled. So this is a very lengthy process, non-homogeneous one. Again, it is the solution. So we will get it as y square minus 2xy minus 2x square is equals to C. Okay. Now again, starting with what we have put, that is small x is equals to capital X plus h. Now all the terms in the whatever answer we got, they are in the capital X. Now you have to convert them into small x. So what will be the capital X? Capital X equals to x minus h. Okay. Now what we got h value starting, that is we got h value as minus 3 and k value as 0. So substitute here h value. So capital X is equals to small x plus 3 and similarly capital Y is equals to small y minus k. That means capital Y equals to small y. Why? Because k value is 0. Okay. So now these two you substitute in the, this is how much equation? 7, 8 or something else. So substitute these values here. Okay, you see that one. This is 7th or 8th equation, I think so. So substitute these values. I have written at the side, these in 7. So now what will be y? Y will be small y square minus what is x? Capital X is small x plus 3 and y is only y, small y minus 2 into x plus 3 whole square is equals to C. Okay. If you want, you can do the square and you can simplify this one. So it will be y square minus 2xy minus 6y minus 2 into x square plus 9 plus 6x equals to 6. So that is y square minus 2xy minus 6y minus 2x square minus 9 to 18 minus 6 to 12x equals to 6. So first write minus 2x square plus y square minus 2xy minus 12x minus 6y and constant term is minus 18 equals to 6. So you can take minus common here. So minus common means it will be 2x square minus y square plus 2xy plus 12x plus 6y plus 18 equals to 6. Okay. So whatever this minus is there, it will go to the constant term. If you multiply, add or anything, if you do for the constant term, you will get the C only. Okay. So this is the solution of the non-homogeneous differential equation. Okay. So I hope so understood. Many example problems are there in the textbook. So try to practice this type of problems you will get for the 10 marks question. That is the 10th B question. Okay. So in MEQ also you have, and also check your progress. So different units also you have, see them. Now this is the unit, 4th unit we have seen. Fifth unit, okay. That is differential equations of first order and first degree. So this you may get for the 10A question, and 10B is the, I have told that exact differential equations are there. So exact differential equations you see there. That is a somewhat different topic is there. If you should know compulsory 4 different integrating factors. Okay. So that concept, if you almost tomorrow is the last day, so I am not going into the topic. Why? Because it will only take almost half an hour time. So now we'll go to the unit 7. It is about the orthogonal trajectories. This is the 11th A question you will get. Okay. So 10A question I have told the 10 marks from the block 2. And block 1 we have seen 2 10 marks questions. Okay. So tomorrow, even today, I will try to complete this 7th unit, unit 7. Unit 7 is the block 3. Okay. Now we are going into the block 3 and 1 10 marks question also from the block 4. Tomorrow I will tell that one morning half an hour, and half an hour I will give the important questions. Okay. So block 3, unit 7, orthogonal trajectories. So practice either homogeneous differential equations or non-homogeneous differential equations. 1 10 marks question you will get. If you understand this procedure, at least half of the problem you may get. If you are getting any wrong also, compulsory try to write in your booklet. At least they will give the half marks for the attention of your question. Okay. So don't leave empty. Try to write the question and write at least half of the solution. If you are not getting whole solution. So now block 3. So in that unit 7. So this is about the orthogonal trajectories. Okay. So in that at the time of the introduction, I have told what are the steps to follow for solving the orthogonal trajectories. First thing is that is whatever the given curve, any family of curves, they will give either the parabola or the square or anything. So that curve you have to differentiate and you have to eliminate the constant term in the given curve. After eliminating the constant term, that is wherever you will get dy by dx, you have to substitute it as minus dx by dy. Then after that, you have to do the integration. Okay. Those are the steps. First one is differentiate 1 with respect to x and both sides and form a differential equations by eliminating constant. by eliminating constant. Okay. Now second one is replace dy by dx by minus dx by dy. This is the second one. And third one is on integrating, we get the required on integrating we get the required OT. OT is a shortcut of required orthogonal trajectories. Okay. First one is you have to take the given curve as the equation one, then you have to do the differentiation. And we have to form a differential equation by eliminating constant term. So in some they will have theta, in some they will have C or A or B, like that, any different terms will be there. So you have to eliminate that term. And the second step is replace dy by dx by minus dx by dy. Then by doing the variable separable method, you have to separate the variables and that you have to do the integration such that you will get OT. Okay. So you will get, we'll see one problem, that is x to the power of 2 by 3 plus y to the power of 2 by 3 is equal to a to the power of 2 by 6. Okay. This you have in MBQ or somewhere it is there. You see whole question. Just I am writing whatever the curve it is there that is given. I have written this. Okay. So now in the solution, first here only I am writing in the question. This you take it as equation 1. Now differentiate 1 with respect to x on both sides. Okay. So this is x to the power of n form. So if you differentiate that, what will come? N into x to the power of n minus 1. If you have any doubt about this formula, see x to the power of n is equal to n into x to the power of minus 1. So here our n is 2 by 3. So 2 by 3 x to the power of 2 by 3 minus 1 plus 2 by 3 y to the power of 2 by 3 minus 1. This a is the constant here. So it will become 0. Okay. So now it is 2 by 3 x to the power of 3 minus 3 plus 2 means minus 1 by 3. And this is 2 by 3 y to the power of same minus 1 by 3 equals to 0. So here y you will get as dy by dx. No, we have forgot this. With respect to y means it will get as dy by dx. Here also. Okay. So for x variable, you will get dx by dx. That value is 1. So that's why we will not write here the differentiation order. This one. Here, whenever it is other variable, compulsory you have to write that first order differentiation. Okay. So now you can take 2 by 3, 2 by 3 common, and when you will go to the right hand side, it will become 0. Okay. So only left is minus 1 by 3 plus y to the power of minus 1 by 3 dy by dx equals to 0. Okay. Now what is the second steps? Now we got the differential equation with the first order. Now and even constant term is eliminated. So we have to replace dy by dx by minus dx by dy. Okay. So dx to the power of 1 by 3 plus y to the power of minus 1 by 3. And here minus it is there. So minus of dx by dy equals to 0. Now if we take this 1 by 3 is equals to y to the power of 1 by 3 dx by dy. Okay. By variable separable method, what we get? This dx you have to get in the numerator. So you will get it as dx by x to the power of 1 by 3. And here dy by y to the power of 1 by 3. Okay. think we have done wrong. Here we have minus 2. Here it is minus is there, minus is there. Okay. You check to the quotient. So minus means you will have 1 by x to the power of 1 by 3, and this is 1 by y to the power of 1 by 3 dx by 3. Okay. So now you do the cross multiplication. So you can write here by now variable separable method. If you do the cross multiplication, it will be y to the power of 1 by 3 dy is equals to x to the power of 1 by 3 into dx. X to the power of 1 by 3 dx. Okay. Now on integrating, this you can write just like this. Why? Because first you have to get x term. No? First you write x to the power of 1 by 3 dx is equals to y to the power of 1 by 3 dy. Okay, just to interchange this one. Now on integrating, we get integration of x to the power of 1 by 3 dx is equals to integration of y to the power of 1 by 3 dy plus. So now it is in the form of x to the power of n of integration. X to the power of n of integration means it is x to the power of 1 by 3 plus 1 by 1 by 3 plus 1 equals to y to the power of 1 by 3 plus 1 by 1 by 3 plus 1 plus. Okay. So 1 by 3 is 3 plus 1 is 4. That is x to the power of 4 by 3 by this is 4 by 3. It is equals to y to the power of 4 by 3 by plus. Okay. Now these two are same, no? We can write it as x to the power of 4 by 3. If you take this as inside, that is minus y to the power of 4 by 3. And whatever in the denominator is there, you multiply with c. That is c. So c to the power of another 80 constant term, it will be c only. So keep like this one. So the x to the power of 4 by 3 minus y to the power of 4 by 3 equals to c is the required OT. Orthogonal trajectory of the given curve. Okay. So this is the procedure to find the orthogonal trajectories. So even simple problems are also there and somewhat complicated also there. So try to solve those problems. So in OT only you have solvable for P and solvable for X problems are also there. So those are the almost they'll get for the 5 marks questions. Okay, try to solve that one. Next unit 8. So unit 8 is simultaneous differential equations and total differential equations. So in that, so like these problems will be also there. Solving the simultaneous linear differential equations of the form. Okay, these you will get for the even 10 marks questions. Unit 8. In the simultaneous linear differential equation of the form. At the time of introduction, I have told what are the simultaneous linear differential equation of the form. Okay, that is dx by p equals to dy by p equals to dz by r. Okay, the equations whichever in this form will be there, those are called as simultaneous linear differential equation. How to solve such type of problems? In that also I have told two different methods are there. One is direct, like this 3 terms will be there. From the you have to take any 2 terms, then you will get one solution. If you take another 2 terms, it may be 1 and 3 or 2 and 3 or 1 and 2. Okay. By taking first 2 terms, you will get one solution. Secondary 2 terms, you will get one solution. That is one method. Okay. And second method is if you take any 2 terms, you will get one solution. But when you take another 2 terms, on doing the integration, you will not get the solution. So you have to substitute the here whatever in the first taking two terms, you will get the solution. No, that solution you have to substitute in the this two terms. Again, you will take no in that and you have to solve the problem. Okay, different types will be there in this. One is the direct one. They will be in this form. You have to take two terms and here another time two terms and you have to find the solution. Okay, we'll see one example of that one. Solve the system of equations. Okay, the equations are given as dx by yz equals to dy by zx equals to dz by xy. Okay. So now it is in the form of dx by t equals to dy by q equals to dz by r. Now you take any two terms, first, second, or second and third, or 1 and 3. Okay, it's your wish. You can take anything. Okay. So now you write here in the solution. Take first two. Either you can call it as ratios or terms. Okay. Or 1 and first two means 1 and 2. Okay. So we get it as dx by dx by yz is equals to dy by zx. Okay. So now here we can cancel z and z here. If we cancel, what do you get? Dx by y equals to dy by x. This is the simple one. Okay. All the problems will be not so simple, so they will be somewhat complicated. Now you cross multiply this one. That is the method is variable separable method. Okay. If you cross multiply, what you get? X into dx is equals to y into dy. So now on integrating, what do you get? Integration of x into dx. Minus I am taking inside now only, so minus y into dy equals to c. Okay. So now integration of x is x square by 2 minus y square by 2 equals to c. So this is x square minus y square equals to c. We take it as c1 because it is the first two term solution. So it is c1. Now you take any either second and third term or first and third. Anything you can take. Take first and last term. So first is dx by yz equals to last one is dz by xy. So your y will get cancelled. Now we get dx by z is equals to dz by x. Now you do the cross multiplication. Okay. So you will get x into dx is equals to z into dz. So now on integrating. So integration of x into dx minus z into dz is equals to c. Here it is c2. Implies x square by 2 minus z square by 2 is equals to c2. That is x square minus z square equals to c2. Okay. So that is 1. Now you take this as 2 and this as. Okay. So we got two solutions. This is one solution and this is another solution. If you take these two means you will get y square minus z square. Okay. Anything you can take. But the thing is you have to take first two terms and after that another two terms you have to take this one. Actually 3 you will get, but anything you can take as you will get the answer same. This here you get y term instead of this. So the required solution is x square minus y square and x square minus z square are independent. The required solution is phi of x square minus y square comma x square minus z square equals to 2. Okay, like this we'll write the solution for the simultaneous linear differential equations. So whatever take out the c values, so you will get the only these two, x square minus y square, x square minus z square. If you take another term, y square minus z square equals to 0. Okay. So this is the procedure how to find for the when the whatever the problem it is there, it is in the simple form. Okay. So in this only another method is if direct integration is not possible, then we have to substitute the first taking two term solution in the second one. Then you will get the answer. So this is the 10 marks question, whatever I have to. So another problem is if dx is the second method, dx by x into z of z square plus xy is equals to dy by minus yz z square plus xy is equals to dz by x to the power of 4. Okay. So these are the three given terms are there. From this, we have to find whatever the same procedure we have followed, no same like that only you have to do. You can take this as one. So here, if you take first and last, you can't do direct differentiation. Okay. Or second and third also you can't do direct differentiation. But here, for these two terms, first and second, if you cancel out z square plus xy, z square plus xy, and y and z and z, then you will get x and y. And you can do easily integration. So one solution you will get easily, but second solution you will not get as a direct procedure. So now take first two terms. So dx by z into z square plus xy is equals to dy by minus yz plus x. Okay, this and also z will get cancelled. So what will have dx by x equals to dy by minus 5. Now we do the cross multiplication. So already they are in the form of variables only. Now do the direct integration. On integrating, so integration of 1 by x dx is equals to minus, we will take common 1 by y into dy plus c1. Okay. So this is log x. If you take this minus this side, it will be log y equals to log c1. So log a plus log b is log of xy equals to log c1. Okay. I have told that if all the terms you are getting log, then you can take for the constant term as a log. Now log on log both sides will get cancelled. Xy equals to c1. Okay. So now if you take any this term, that is first and second and third, if you take for the next solution, you can substitute wherever xy is there, you can take it as a c1. Okay. So if you take second and third, you will not get direct integration, or else 1 and 3 also if you take also, you will not get the direct integration. So such type of problems, whatever the solution you will get here, that solution you have to substitute in the second one. Okay. So first equation we have to know. So this you can take as 2. Now either we can substitute xy equals to c1, substitute xy equals to c1, or we can take x equals to c1 by y. So if xy is there means you take it as c1, and again if x is there means you take it as c1 by y. Okay. Substitute xy equals to c1 or x equals to c1 by in last two terms. Okay. In the last two terms of equation 1. Okay. So it's this one. Option is 1. Okay, now we take it as that is dy by minus yz into z square plus what is xy? Xy is c1. equals to dz by, it is x to the power of 4. No? X to the power of 4 means in place of x, we'll write it as c1 by y to the power of 4. Okay. Now, if we do the simplification, what will you get? This y term is there. You take this side, you get it as, that is separating the variables. So dy by into this one, that is c1 by y to the power of 4. Here minus y is there. Minus y is equals to this z into this term, this side cross multiplication. Okay, we do the cross multiplication. So z into z square plus c1 into dz. Okay. This is z square into z is z cube plus z into c1 into dz. And this is dy. We have written here. You can write this as c1 by to the power of 4 into dy. Okay, here also same one. Now, on doing integration. On integrating. So C1 is the constant term. No? You take that outside, that is minus term also, minus C1 to the power of 4 integration of, here y to the power of 4 is this. Okay. So C1 by y to the power of 4. And here y only 1 is there. That means into 1 by y, no, 1 by y. So 1 by y means it will become C1 to the power of 4 by y to the power of 5. Okay. So that if you do the interchange and if you do the simplification, you will get it as dy by y to the power of 5 is equals to integration of z cube plus z into c1 into z plus c2. Okay. Now, so y to the power of 4 minus c1 to the power of 4 is integration of y to the power of minus 4. Minus 5. We'll take it to the numerator. Minus 5 into dy is equals to z cube. What is the, or is keep like that on? Next time we will do the integration. Now y to the power of minus 1 means we'll write it as c1 to the power of 4 y to the power of minus 5 plus 1 by minus 5 plus 1. Okay. Now z cube is z to the power of 4 by 4 plus z integration is, that is z square by 2 into c1 plus one more term is c dash 1 to the power of 4. Now this minus 5, 4 means you will get minus 4. So minus c1 to the power of 4. This is y to the power of minus 4 by minus 4 equals to z to the power of 4 by 4 plus z square by 2 into c1 plus c2. This minus minus you can cancel, and if will that y to the power of 4, if it comes to the denominator, it will become y to the power of plus 4. Okay. Now that is c1 to the power of 4 by 4 into y to the power of 4 is equals to z to the power of 4 by 4 plus z square by 2 into c1 plus c2. Okay. So now this c1 should not be there, but because this is of the solution for c2, no constant term. So now you take out this c1. So you take out that c1. C1 we have to substitute it as xy. Okay. So now put here. Now substitute c1 is equals to xy. So here if you take xy to the power of 4 by 4 y to the power of 4 is equals to z to the power of 4 by 4 plus z square by 2. Again here C1 means x, y plus C2. This is also very lengthy one. So now this, if you multiply y to x to the power of 4, y to the power of 4 by 4, y to the power of 4 is equals to, if you take 4 LCM here, it is z to the power of 4 plus 2x y z square plus 4 into C2 means again you get C2 only by 4. Okay. So now y to the power of 4, y to the power of 4 will get cancelled. Here 4 is there. This 4 and this 4 will get cancelled. So it is x to the power of 4 minus z to the power of 4 minus 2x y z square equals to C. Okay. This is C2 one. So what is the complete solution? Complete solution is, so pi of, what is the first one? First one is xy comma x to the power of 4 minus z to the power of 4 minus 2xy z square equals to 0. Okay. So this is the procedure of finding the simultaneous linear differential equation. When one solution you can do easily with the help of the integration. Second one it is possible means the first solution you have to substitute in the second one and you have to find the solution. Okay. So this is about the 8th unit. So 9th unit is small problems. 9th unit you will get only the 5 marks questions. Some problems, example problems I have told in the introduction. You can see them. Okay. So tomorrow we'll see the block 4. So block 4 any 1 10 marks question I will tell. You can see there. 8 almost I have completed 1 10 marks question. Okay. So 9th unit it will be there only. I have told homogeneous linear differential equations of second and higher order. To find the factorization is there, no? That factorization problem will be there. Only 1 5 marks problem will take this one. So unit 9. So problem will be like this. That is d square by solve it will be there just question. Solve d square y by dx square minus 6 dy by dx plus 8y equals to 0. Okay. Question will be asked like this. So in the solution, this d square y by dx square I have told already, that is d by dx means we'll write it as d. Okay. This is called as differential operator. So it is d square minus 6 d plus 8 into y equals to 0. Okay. Whatever the above equation is there, that you are writing as this one. So if you take it as equation 1, auxiliary equation is r square minus 6r plus 8 is equals to 0. So you have to do the factorization of this one. Factorization means if you do the multiplication of the two numbers, you have to get these two terms, and if you add, you have to get the middle term. Okay. So r square minus 4r minus 2r plus 8 is equals to 0. Minus means you will get minus 6r. Minus into minus means plus r square. Okay. So r if you take common, r minus 4 minus 2 into r minus 4 equals to 0. So r minus 2, r minus 4 equals to 0 implies r values are 2, 4. So the solution is y equals to, so first one independent solution are, that is pi 1 of x equals to first solution e to the power of 2x and pi 2 of x is e to the power of this 4x. So solution is yc is equals to c1 into e to the power of 2x plus c2 into e to the power of 4x. So like this, if simple, these two are the distinct roots we have got. 2 is one root and 4 is another root. If we get the same roots, that is 2 comma 2 or 1 comma 1 or minus 1 comma 1, I have told that one how to write the solution. So like this, these problems are important. Compulsory 1 5 marks question you will get from the Unit 9. If any example problems are there in your textbook, so try to solve them and practice those all problems. So tomorrow important questions and block 4 I will give. Okay, we'll see tomorrow.